Thank you very much. So this may be one of the longest titles to a talk I've ever given, but healthcare is intrinsically a data-driven enterprise, but the way that we use the data and transform it into compassionate care brings in all aspects of the human experience. So what I'm going to try and do today is cover what the looming role of the IoT in healthcare is and how that translates into the experience of the caregiver as well as the physician. Talk about sensory overload, sensory disintegration, signal and noise management, and then what I call the behavioral symphony of wellness and the creative reconstruction of healthcare. So just quick survey, how many of you have ever worn a Fitbit or pedometer of any kind? Okay, and how many have one on today? Okay, maybe 10% at most. Okay, I want to come back to that. How many wear a multifunctional sensor or multiple sensors? 3, okay. And how many believe that wearable sensors will become just a huge pervasive consumer market? Maybe 80%. And how many of you have ever emailed your doctor directly? Cool. We do about 25,000 emails a day between our members and our patients. And how many of you have given your physician other types of digital data other than email? Wow, about 8, okay. So the first thing I want to talk about is what I call the sci-fi generation and the implications for healthcare. So there's this concept that I like to think of as the compression of transformational time. So if you look 5,000 years ago, 500 years ago, 5 years ago, the experience of one generation to the next really didn't change much at all, but in the last 50 years that's really changed. And about 5 years ago, AT&T, some of you may have seen it, had an ad, and there was about a 15-year-old talking to his 12-year-old brother and his 12-year-old brother's friend. And he put his hands in his hips and he said, well, back in my day when I was your age, I had to wait forever to download a video. You guys just take it for granted. And so the technology, the exponential changes in technology are really having experiential and transformational changes on a generational scale that's been compressed from 20 to 30 years down to 3 to 5 years. And so with this kind of zeitgeist, I refer to the current generation as the sci-fi generation because it's almost impossible to imagine how much more acceleration there's going to be in the human experience based upon technologic change. And I'm a senior consultant to the Tricorder X Prize, and I mentor hundreds of startups. And the stuff that's happening, and Stephen was referring to a lot of them earlier, you know, magnetic resonance and intense spectroscopy analysis, the non-invasive monitoring of human biology is just exploding. And so healthcare is really at the vortex of this. So if you look at all the changes in digital technology, and if you look at how little we know truly about how the human body operates, healthcare is really at the center of the vortex in more ways than one. So the doctor's brain is pretty constrained. So I was at a policy committee meeting in Washington 2 years ago, and these were like the smartest guys in healthcare. And we had a patient advocate in the room, and the patient said, you know, she was complaining, my doctor didn't even know that my statin and my antibiotic interacted. And I panicked and went to my smartphone and started searching because I didn't know which antibiotic would react with which statin. And then I looked up, and the entire room of top-notch doctors in the world were doing the exact same thing because none of us knew which statin interacted with which antibiotic. And so we're way past the fact that the network is your brain, doctor. So we're really well into an era of sensory overload and sensory data disintegration. So the information overload is critical. Wearable sensor data in the health IoT is rising exponentially. Converting these streams of disparate data types into actionable information, aka clinical decision support, remains very primitive, very primitive. So the impact is we have very stressed doctors and many missed opportunities. And there's actually an article in the Wall Street Journal just last weekend called Why Doctors Are Sick of Their Profession. And there is a serious malaise in terms of what % of docs regret going into medicine, what % of docs would discourage their children from going into medicine. And they listed all the tired answers, you know, about lack of professionalism and time pressure and yada, yada, yada. And it's all true. Didn't even talk about the information overload that is underpinning a lot of this stress, nor did any of the cures recommended address any of what I believe are the real solutions to the healthcare crisis today, which is extracting signal from noise, implementing advanced clinical decision support, virtual care and self-care, visualization tools to support a dialogue where you can communicate quickly and efficiently with a patient. I'm going to come back to that. Activating people in their own health journey, and addressing social determinants of health. So this exponential data tsunami, it continues to accelerate at an exponential rate. 90% of all digital data was created in the last 2 years. 90% of all, this is my projection, 90% of all new clinical knowledge will be generated in silico by the year 2020, not through scientifically controlled studies, but through in silico research. And there's emerging data interrogation techniques that allow us to look at a correlation and test it in multiple different environments with different context and data sets. And if we can reproduce the correlation over and over again, there's a way to infer probability of causality. Randomized clinical trials and traditional clinical research are really going to be reserved for 3 situations: where the inferences are ambiguous, where the conclusions are so critical and impactful in health that we must have a clear, viable conclusion, and then for controlled long-term trials. The omics, genomics, transcriptomics, proteomics, lipidomics, reactomics, metabolomics, exposomics, socialomics, wearable sensoromics are going to generate 10 times more data in 5 years and 100 times more data in 10 years. I chair the Clinical Electronic Health Record Genomics Work Group for the Global Alliance for Genomics and Health, sponsored out of the Broad Institute at Harvard, but involving all the genomics consortiums around the world to try and create the interoperability that allows us to pool the data to really begin to understand. And there is no such thing as a sufficient size sample to do genomics research, because there are many, many multiples of more viable genomes than there are people who have ever walked the face of the earth. So what is an adequate sample size? Not even if we had every genome ever in existence would it be large enough to really untangle the complexity of the human genome. Microbiomics, I'm going to come back to that. The ecosystem in our gut has 10 times the number of bacteria cells in our body, 100 times as many genes as we have in the human genome. You can tell 5 years after a child is born whether they're born by vaginal delivery or C-section by their microbiome, because they get the microbiome in the mother's skin from a C-section. A good friend of mine, who I won't name, recently had a baby, and he inoculated C-section. He inoculated the baby with the vaginome, the bacterial microbiome, right before birth, which undergoes massive and dramatic changes in the 2 weeks before birth, and especially in the last 3 or 4 hours before birth. So we're just beginning to understand this stuff. And then the healthcare Internet of Things and wearable sensor data is going to generate massive streams of dynamic data. So I created this term called the healthcare Pleco system, because we're seeing this exponentiality across multiple platforms. So Pleco system is a contraction of multi-platform ecosystem. So the internet, cloud, ubiquitous access to data, smartphone with video dial tone and modality steering, the socialome. James Fowler and others have done amazing research here. And his most recent publication, he looked at the genetics, 1.5 million markers across a social network. And he found, to his surprise, he was expecting to find something, but he actually found that the people in your social network are related to you as closely, on average, as your 4th cousin. So the way you choose your social network has a lot to do with the genetics of the people you meet. And a lot of that maps to smell, which is really interesting because that's one of the most dynamic and volatile aspects of genetic evolution. So we have the internet and the quantified self. I'll come back to that. The exposome. We have pervasive sensors everywhere. Look at environmental influences of health. The $1,000 genome. So all of this omics stuff is becoming incredibly cheap. The exponential decline in cost of sequencing is super Moore's law, and it will be a couple $100 soon, and it will be foolish, frankly, not to have your full genome sequenced and available to your doctor as a standard community practice very soon. Electronic health record data, we just have billions of encounter visits in our health records to data mine. Predictive analytics, persuasive technologies. BJ Fogg out of Stanford has done tremendous work in this space about how to take data and use it to motivate people. There's a real science around it. The role of avatars, artificial intelligence, robotics, machine learning, heads-up displays, 3D printing, augmented reality. All of these things are moving at an exponential speed, and they're all being convergent and synergistic in the impact in healthcare. The quantified self movement is really getting ahead of steam. Larry Smarr, many of you probably know, astrophysicist in Stephen Hawking's labs, first person to set up a supercomputer center in the world, helped put together the team that invented virtual reality and now is deep into microbiomics. Mike Snyder, the chair of genetics at Stanford, has an intrapersonal omics, multi-omics profile study, IPOP. I'm a subject of that, so I'm one of the most quantified people in the world with terabytes of data about me, and I contribute every 3 months and whenever I get sick. 4 microbiomes, 6,000 blood assays. Jessica Richmond is doing citizen science with Ubiome. Lynn Davies doing Curiosity, where you put all of your data into one source. There's so much going on in this space. It is mind-blowing. And as I say, I do a lot of mentoring of startups. How many startups are really beginning to think about what it will be like in the very near future for everyone? So this, I'm assuming some of you know Larry, but this is Larry standing in front of his wall. And what he's showing in this picture is those are histograms of basically the species in your microbiome. So there's terabytes of data represented there. And he does it by full sequencing of what's in the bacteria in your gut, and other people do it for viruses and fungi. And what he has found is that when you take a series of antibiotics, you create a mass extinction of the species in your gut that dwarfs the mass extinctions that have occurred from various meteors and supervolcanoes in the world. And we now know there's almost 100 diseases that have a very characteristic signature of your microbiome. And not to mention the fact that the microbiome has a very direct interaction with the genome and conditions your immunome. Your whole immunologic response to the world is conditioned early in life and evolves. And your neurobiome, and your connectome in your brain, how your brain is wired. So the connections between these massively complex data sets is extraordinary. So intuitively, we all understand what geometric change is, but it's very hard to wrap our minds around exponential change. So in healthcare, the physicians are already reeling under the fact that we can now see a patient in the emergency room and electronically get their health record from 5, 10 different institutions. And oh, by the way, they don't show the same allergies, they don't show the same problems, they don't show the same medications. So we're now getting more information than they can possibly handle at a geometric rate. So they get 3x, 5x, 10x. But with the Pleco system overload and multi-omics and wearable sensors, there's going to be an exponential growth in information available, and it is not even imaginable what's going to happen. And docs really can't even, I have the hardest time talking about this with physician groups because for all of history, a doctor has not put anything into their chart until they reviewed it. So the notion that there's data streaming into the chart that's going to have a backstop of intelligent filters and escalators is just anathema to them. I get shouted out of the room when I say, get over it. Because it is coming, it has to. So where is healthcare IoT in the Gartner hype cycle? And this is a quote from Mobile Health News. Mobile health monitoring is approaching the bottom of the so-called trough of disillusionment, and will need another 5 to 10 years before reaching its plateau of productivity and steady market adoption. That's probably about right. And then another one from International Data Corporation saying wearable data shipments worldwide will rise over 5-fold in the next 4 years, from 19 million units to 112 million units. So there's emerging data sources and news, nanobots for detecting all kinds of things in terms of early cancer. So this is serious research and startups that are creating nanobots that scan for specific DNA sequences circulating in your blood to know if you've got a recurrence of your breast cancer, your colon cancer. You could program them to say, here's what you look for. Let me know when you see some, because that means you've got an early recurrence. Point-of-care testing using the PCR, polymerase chain reaction testing, which is how we sequence DNA. I have a project that I'm starting now, so that when someone comes into the clinic, hopefully before they even get there, they can go to a local pharmacy and have it done there in a couple of minutes for a couple of bucks and tell them which type of influenza you have. Is it an H1N1? Is it an H2N5? Is it the dreaded H7N9 from China, the so-called avian flu with a 40% mortality rate? Or is it a respiratory syncytial virus? And oh, by the way, an antibiogram as well to say yours is or is not resistant to the drug we recommend for that virus. So we can start triaging people, go home, go to the clinic, let us know if you get these symptoms, take this drug or not, based upon a 5-minute, $5 test in a drugstore. And oh, by the way, the vendor I'm working with who won the tricorder, not the tricorder, but the X Prize for sensing, based out of Boston, was just recently approached to develop that same technology for the Ebola virus. And so they're in production right now to take these devices to be able in a minute to be able to know if someone has Ebola. Swab of the throat, put in the device, you know. Autism is really fascinating because there's over 600 single nucleotide polymorphisms, and they all map to 4 areas of neurogenesis. The scaffolding that produces the brain itself, and then the pruning of the scaffolding. And so all of these map to that. And those of you that remember your genetics, there's a Hox-like gene that determines limb growth, and whether it turns into an arm, a wing, and a leg, sort of like a super regulator. And it's my hypothesis that there's a Hox-like gene for autism because all of these defects map to these 4 functions of neurogenesis and neuropruning. And that now that we have 10,000 complete genomic sequences of autism, we can start looking for what the cause is. And my speculation is that because autism is so disproportionately represented in intelligent people and in Silicon Valley, that it may well be an unintended consequence of deliberate experimentation in those elements of the brain that accelerate the rise of intelligence of the human species. And the brain of the human species has grown faster as an organ than any other organ in any species ever. So there's reason to believe that there may be unintended consequences of this genetic experimentation. Schizophrenia, pooling of data, the work that I'm trying to do with the Global Alliance for Genomics and Health, a similar group put together the genomic data from multiple different sources, and in a matter of months, they tripled what we know about the genomics of schizophrenia. Well, why does that matter? There are almost 2,000 approved experiments right now to do genetic manipulation, and it won't be that long. With all these exponentials, it won't be that long. Some of the stuff is really, really refractory because of its complexity, but it won't be long before we start having genetic cures for some of these really horrible diseases. And then collaboration requires semantic interoperability, which is why I'm involved with the global initiative for genetics. So with this flood of data coming into physicians who are already like really stressed out, and I can't tell you how stressed out they are with the flood of data and their inability to interpret and act on it confidently, I've created 5 filter sets that we need to have as a backstop so that we can let the stuff come into the chart and have the doctor have some confidence that there's some intelligent escalation of what the data says and what's relevant to that patient. So first of all, obviously the value, numerical and graphical values. Second is the trend and velocity. So for glucose, if a diabetic has a blood sugar of 125, you might say, that's great. But if 15 minutes before it was 160, that's horrible because they're headed for a glucose of 40 and brain damage. And so this is what we see in our brittle diabetics. So we need the first derivative, the velocity of change as well. Third is aggregate values, and there's already evidence and a proof point on this where and there's no single value that tells you how well hydrated a person is, and you can over-dialyze a patient and leave them in essentially shock, but it takes multiple parameters to understand that. Then there's the trend of the aggregate value and the velocity of that. And then there's textual data with NLP, natural language understanding, and clinical language understanding. These are all products on the market today. And then finally, you can double all those because we know that not any 2 individuals are the same. My wife and my daughter both have a normal body temperature of 97 degrees. When they are 98.6, they know they have a fever. They go to the emergency room, they say, I've got a fever. They say, oh, no you don't, 98.6. Well, sorry, they do. But for most of us, 98.6 actually is high at certain times of day and low at other times of day because there's a circadian rhythm that we all follow and it's unique to each of us. So what we need to do is to take these data streams and create the personal nomograms so that we actually can look for outliers based upon our personal nomograms, not homogenized population-based nomograms. So what is the topology of the sensor network and the avalanche of data in what Stephen described as the first mile of what he has calculated as the 3,682 connected devices? So from edge, the sensor, to the cloud, whether aggregated or federated, the various data types, the parameters, the principles. The way I like to think of this overall is that we need to know what data needs to be aggregated to be useful and what's the lowest point in that value chain where it's possible to aggregate and apply analytics. So one of the key principles of analytics and big data is don't drag all the data to the analytics side, but drag the analytics to the data. So my view is let's push the analytics as far out as we possibly can so that we can keep the data local. We can always suck it back up if we find something else, but not to try and put everything into a single database and do the analytics there when you can already eliminate a lot of noise lower down the food chain. And then with the multiple data types and the parameters you need to sense, normalize, transform, aggregate, store, compute, analyze, escalate, compress, archive, and purge. All of these functions need to be managed in a topology that makes sense so you know when and where you're doing what. So there are three principles that I use. The accordion model of learning, where you think you understand what's noise and what's signal, and you put the analytics locally and you just store the noise until there might be a further use. But at some point in time, with new technology or new understanding, you open the accordion up again and you say, wow, look at these new things we need to build filters for. And then you close it back down with those including those new filters, and periodically with all data in asynchronous modes, you're doing this accordion action of being open to new knowledge and applying it, and then shutting it back down and just applying it in a systematic way. Second one is, how do you distinguish machine-to-machine escalation versus machine-to-consumer? Consumer can be the doctor or the person or their family. And then, again, move the analytics to the data rather than the reverse. So what do we need from sensor device manufacturers? So the traditional features are values and dimensions, total cost of ownership, reliability, volume pricing, durability, and multi-user support. The new requirements are, and this is a big one, security. So Apple just announced yesterday that anybody who uses their health kit, it's an open API set for all of their health apps, is no longer allowed to play in the Apple space if they store the data in the iCloud. Anybody want to guess why? So it's not just your nude selfies, but it is your clinical data that Apple doesn't want in the iCloud. Transparency in open source components and open source strategy, and failure issues, open FDA. The FDA is releasing everything about all device manufacturers, failure rates and failure types. Self-awareness of location and failure, self-reporting, self-healing, full IoT integration compliance. And then what we need in the future, and I'm just going to skip this in the interest of time, but there's a whole lot of future requirements we need to meet. So how many of you heard that the FDA shut down the most popular genetics testing group, 23andMe? Because I just happened to be in Boston with Tim O'Reilly at his annual Health Foo about a month after that happened, and we had one of the founders of 23andMe, we had one of the attorneys that supported the FDA, we had one of the board members, Esther Dyson, there, and we had this, it was an unconference where we organized, so we set up a debate about 23andMe and the FDA. And what the FDA did is there's the thing called ascertainment bias, where you discover a certain correlation, a certain population, and then you overgeneralize it to a population that wasn't pre-selected on the basis of the first population. So there's a lot of ascertainment bias, and the FDA just wanted to say, tell us how you do this so we can understand the numbers you're giving your consumers, and 23andMe stalled. But what I proposed to the group in that discussion a year ago is that the FDA is asking the wrong question. The right question is, I'm a doctor, and I read the genetics literature, and I see that this patient has a genotype that means that this drug is more effective at lower risk than any other drug in class, and yet there's no FDA-approved indication for that drug for that patient. I'm going to give it to him, and I am going to be at risk of getting sued because the FDA hasn't had time to review that. Well, that's going to start happening in mass because the amount of new information generated, there's an impedance mismatch between new knowledge and any of the FDA regulatory processes. So what I'm recommending the FDA is that they turn from a regulatory agency into one that's a certification industry that does crowdsourcing from academics around the world. They certify people to keep up with the pace of knowledge change and manage it more effectively. Ironically, Grainger, who's one of the biggest suppliers of farm equipment and stuff, I happen to know them because I grew up on a farm, the feds told them, you know, we can't keep up in regulating the quality of your devices with all the ISO standards and so forth. So we just can't do it. You're going to have to do it yourselves, but you still have to use our procedures that aren't working for us. So we have a lot of work ahead of us to get the regulatory environments to address the fact that knowledge is growing exponentially, and all of the review processes have an intrinsic impedance mismatch. So with all this happening, there's this battle between the utopianists and the dystopianists. And there's a whole series of great books, the utopianists, Peter Diamond and Abundance and Byron Reese on how bright the future is. And then you've got the other side of the coin where you have the second machine revolution calling out the other side. So Google has already acquired 8 robotics companies and hired Ray Kurzweil to head up their machine learning program. And they now have a contract with Foxconn. So all these poor Chinese that were pulled out of the farms and told, come work in this sweatshop and you will be happy, are now being told, we got a robot, we don't need you anymore because health insurance for robots is much less. Steven Schwartzman, CEO of Blackstone, $3 trillion, I wrote that wrong, $3 trillion under management, toured 40 countries at the beginning of the year in 4 months, and interviewed all the prime ministers, premiers, presidents, and their number one concern was structural unemployment. So everybody says, when they invented the wheel, when there was the agrarian revolution, when there was the machine revolution, industrial revolution, everybody fretted about job loss, and we found new jobs. The difference today is that was arithmetic and geometric change. This is exponential change. And the real risk is that we're creating systematic unemployment at a pace unprecedented in human history. So we need to redefine work and how we think about that. So finally, I'm going to talk about the big opportunities to create what I call the behavioral symphony of wellness and creative reconstruction of healthcare in response to these exponential technologies. So the first is embrace the whole person with the behavioral symphony of wellness. So if we're just treating a diabetic or we're treating a hypertensive, we're missing the point. People spend 99.95% of their lives outside of our clinics and hospitals, and it is their micro decisions every day where health happens. And so we need to consider the whole person, the mind, the body, the soul, their alternative and complementary and integrated medicine that they may engage in, the quantified self, and not the patient. So the healthcare industrial complex is all about the patient. There's this new movement to shift to the consumer-centric view. Well, consumers buy stuff. We need to look at the whole person. Second is community-centric health and wellness. So we know that if you do geomaps of health, and Dartmouth has a health map, that you can show just extraordinary disparities in health in very micro communities, and it maps most closely to income. And some people throw their hands up in despair and say, well, I can't affect the income overnight. But income is a proxy for all kinds of other things that can be fixed. So I like to think, many of you have heard of the notion of cognitive excess and reallocation and the harvesting of that. The MIT Red, how many of you have heard of the MIT Red Balloon Project, where they released 10 red balloons all over the country and they let teams self-organize with a prize to find the GPS locations of all 10 balloons? And I think it was like 40 hours when the first team reported that. Same thing for a protein folded. So I believe there's, similar to cognitive excess, there's compassionate excess that we should harvest. And there's a social app called Nextdoor where you manage it at the hyper-local level in your community. We use it. I'd recommend if you don't use it, use it. It's great. And then there's a global one called Impossible Calm started by an Oxford student, Lily Cole. So I think this is a much healthier alternative to play with these compassionate excess harvest, both local and global initiatives, and more rewarding than playing Angry Birds. Okay, opportunity number 3 is applying evidence-based discipline across the entire life cycle of aid. So there's a lot of evidence that a lot of the aid that goes to Africa or South Central LA is basically a foundation with a hammer and everything looks like a nail and they come in. And there's a book called Dead Aid, as opposed to Live Aid in Africa, characterizing the sort of sordid history of institutions coming in to help and doing more harm than good. And so we need to be able to use evidence-based tools and data to look for what are the gaps in the community, what is the appetite for change, what is the capacity for change, what are the tools and the institutions that have those tools, how do you sequence and synergize those to create evidence-based execution. And finally, the fourth one is privacy versus reciprocal transparency. And truly, what Snowden called out is the fact that we really can't stop this data. I mean, we know that the data is going to end up in the wrong hands. So the question is not how do you prevent the data from getting there, it's a question about how do you provide transparency to who has your data and what they're doing with it. And I believe that's possible. The big challenge would be how do you protect the IP when you have that kind of transparency into the data. A lot of other stuff I'm going to skip. This is just an illustration of the massive numbers of sources of data for an individual person that physicians need to deal with and why we need to have these filters and decision support. Finally, 6 dimensions in the management of personal data. The first dimension is the archetypes of data. Second dimension, the filters I mentioned. Third dimension is the personal nomograms. Fourth dimension is the escalations. Fifth dimension is avatars as brokers, and avatars are going to play a huge role in terms of brokering our data set with other people and other institutions, and I believe that there will be social avatar interactions that broker these activities. And then the question becomes, who owns your avatar and why do you care? Because the more data you feed your avatar, the more value it brings to you, but the more you expose yourself to privacy risks. And then the role of pervasive sensing, I see that the market's being segmented into 5 tiers. The athlete and the warrior for real-time tuning, the acute illness for wireless inpatient monitoring, chronic illness for post-discharge from the hospital, and then restoring wellness through mindfulness. And when I asked earlier about how many ever used a pedometer and how many had one a day, it was only 10%. Digital nannies don't work. So if you're just counting steps, people get tired of it. I got tired of it. What we really need to do is use social networks to bring about challenges and social support for the behavioral change. But in addition, we need to challenge people to become more mindful so that you, instead of looking 3 times a day to how many more steps you need to take today, we want you to extend it to 2 days between looks and then 4 days. So you begin to calibrate more mindfully. And then instead of saying, how many more steps do I need today, you say, oh, there's the elevator, where's the stairway? And become much more mindful about how you exercise, how you eat, how you sleep, and how you pay attention and nurture your social relationships. So how will the digital IoT world shape the future of human evolution? So this is what I call homometricus for the athlete and the warrior, and I believe every high school athlete, varsity, junior varsity, is going to be wearing accelerometers to look for injuries and potential concussion in the I mean, the helmets already exist, and it's in all the major leagues. It will be at the high school and junior high school level. And then there's an evolution that looks more like some of us, called Homogigas. And unfortunately, many of us have back issues as a result. And then thanks to McDonald's, we have Homo fast foodorus. And then in the evolution of the flat panel display, something went terribly wrong. And then finally, visualization tools to support 3 conversations. So we need to really have very effective visualization tools that quickly characterize different options and that allow people to drill down to the data to select their option. And I know I'm running out of time, but the 3 options are the discussion between the patient and their professional care team, the patient with their personal care team, their social network that they trust for that problem, and then the patient with the person that houses that patient persona, because frequently someone comes in the office, they get this download of data, they're overwhelmed, they can't remember it. We do something now called open notes, where the moment we enter a note in our chart, we send it to the patient so they have access to the full medical record note simultaneous with the rest of the healthcare system, that they can sit back in the comfort of their own home and approach it as a person rather than a patient. And the example I like to give is, if you have 3 options for treating a 45-year-old woman with new onset of hypertension and diabetes, and one option is maximal benefit, maximal risk, another option is pretty good benefit but not so much risk, and the third option is pretty good benefit, not much risk, and you really don't have to work that hard to do it. And the woman says, my daughter's getting married in 3 weeks, so give me the easy option for 3 weeks, and then I'll cut over to the high benefit one. So I will go ahead and end on these 2 slides. So what I believe the evolution we need to seek is how to use data to create mindfulness and mindful man. And then a quote from Hubert Humphrey that hangs in Health and Human Services here in DC that moves me every time I read it. And what he said is, it has been said that the moral test of government is how that government treats those who are in the dawn of life, the children, those who are in the twilight of life, the elderly, and those who are in the shadows of life, the sick, the needy, and the handicapped. And everything we do as technologists, if we forget the fact that the democratization of technology is a myth that's been exposed by George Packer in numerous writings, we're missing the boat. We need to actively pay attention to how the benefits of modern technology help bridge the digital divide and the growing economic disparities. So I don't know if I have time for any questions. Nope. All right, thank you very much.